In this example, we're going to sketch plots of the coordinate functions from the given parametric curve. So the given parametric curve we have is the one following here. So this is on the XY plane. And what we're going to try and do is extract the X versus T plot and Y versus T plot from this given parametric curve. So the first thing that I would like to do is, again, to set up some kind of bare bones axes in terms of something Y versus T, something X versus T, really plotting those coordinate functions individually versus the parameter T. But the other thing is we can give a sense of, well, how big do each of these things kind of get on their own? So for example, if we're looking in terms of, say, the X coordinate only first, so the X coordinate only, the leftmost point on this thing looks like it occurs somewhere between minus 2.5 and 5. And the rightmost point looks like it curves, or it looks like it occurs just after 5. So what that means is when we're setting up kind of tick marks for our X versus T plot, it looks like we only really have to go down to, I guess, about minus 5 at the most and a little over 5. So just make 2 of those tick marks, something at like 2.5 and 5. Minus 2.5 and a minus 5. And we can do the same thing for our Y coordinate as well. So looking at the Y coordinate now, vertically, we ask, what's the highest point along our parametric curve? It looks like it happens about 5. And what's the lowest point? It also looks like it occurs around minus 5. So when setting up the tick marks for that curve, we can do the same type of thing. It looks like the lowest point is going to be about minus 5, and the highest point is going to be about 5. All right. So the way that I do this now is I take our parametric curve that's given, and I'm going to break this into points where I see sort of big changes in either something changing from mostly moving horizontal to all of a sudden moving vertically, or something that's moving mostly vertically to something that's moving mostly horizontal. So I'm going to think about this. And again, these are just going to be sketches. I'm going to say, you know what, till about here, where this arrow is, our curve looks pretty flat. It looks mostly flat, if you will. So that'll be kind of the first point that I think about. I'm just going to call this T equals 1. Next, what I'm going to say is, well, in this case, we're moving a little bit to the left here, and we're moving a little bit downwards. That's okay, but that'll be kind of the next point. So I'll just say that's going to be T is 2. Again, we're just going for sketches here. And next, well, at this value down here, we're still kind of, Y is going downwards since our parametric curve is moving down between these points, but we're also moving to the right side, so X is increasing. And then we make a sudden change where X kind of shifts the other way. So I'm just going to make that at T equals 3. The T values here are really kind of just arbitrary placeholders of where we can determine what's happening between X and Y at these different points. Next, I'm going to put another value of T somewhere around there. Call that T equals 4. And my rationale here is between T equals 3, T equals 4, our X value looks like we're moving to the left, but then all of a sudden beyond T equals 4, our X value is moving towards the right. And then I'm going to put one, let's say right at this arrow, say, make that T equals 5. Because all of a sudden at T equals 5, it looks like our Y value, it kind of just stops changing more or less. And then from T equals 5 to this very end point here, our curve looks like it's more or less kind of just flat there. So I'll call that last point that we have at the end, I'll call that T equals 6. So the idea is once we have those discretized points now, we'll just ask ourselves what's happening for each coordinate between those points and try to sketch that on the actual coordinate plots of X versus T and Y versus T below. And we're going to do this one at a time because I really want us to focus on what's happening in X or what's happening in Y individually to extract that information about X and Y carefully. All right, so Let's start off at t equals 0. And we have t equals 6 all the way. So I'll just mark kind of 6 spots on here. Again, these are just going to be rough sketches. So from t equals 0 to t equals 1, what's happening for x? It looks like we're moving horizontally. So x is changing, and x is going from about 5 to x is going to about 2.5 or so. So from t equals 0, x is equal to 5. So it's good to probably write that information first. So at t equals 0, x is roughly 5. And then when t is 1, our x value now at t equals 1, we're about at minus 2.5. So at t equals 1, we are down here. So our x plot, it does something like that. Our x value, it decreases. Again, the more points that we put between t equals 0 and t equals 1 here, kind of the better representation of that curve we can get, but more or less is kind of just an approximation. All right, just a sketch. All right, so let's see what happens now. We are at t equals 1. What happens when we're at t equals 2? Well, x decreases a little bit, again, because we're moving just slightly to the left. We're moving just slightly to the left here in terms of x when we're at t equals 2. And t equals 2 happens just about halfway between minus 2.5 and 5. So at t equals 2, we are somewhere, about halfway between minus 2 and 2.5, or minus 2.5 and 5. So we can draw that kind of curve. Now what happens from t equals 2 to t equals 3? Well, if we're looking at x only, we're moving to the right in terms of x. Our horizontal motion between t equals 2, t equals 3 is to the right. So at t equals 3, our x value, though, we're smack dab at 0. So let's see what happens now from t equals 3 to t equals 4. From t equals 3 to t equals 4, we're moving horizontally to the left. And since we're moving horizontally to the left, our t value, or our x value, is decreasing. And we're decreasing to a value of x of about a little bit over 2.5. So somewhere around here again. Oops. And now, from t equals 4 to t equals 5, we're moving to the right a little bit, or horizontally, we're moving to the right to get to the next x value at t equals 5. And this is somewhere between minus 2.5 and 0. Okay. All right, and finally, between t equals 5 and t equals 6, we are moving to the right. In other words, we're moving horizontally to the right, so our x value is increasing. So from t equals 5 to t equals 6, our x value looks like it's grown. Actually, it's grown beyond 5. So we're going to be somewhere up here. So as a real rough sketch of our x coordinate versus t, that's what it can look like. Again, the more individual t points that we kind of use in this parametric curve, the better representations we'll get. In this case, we've only really used 7 points, including the first point at t equals 0. All right, let's check out what happens for y now. So for y, we're only going to care about what's happening from point to point in terms of vertical movement. So when we're at t equals 0, our y value, we're about t equals 5, or we're about y equals 5. So let's place that on our plot. At t equals 0, we're at y equals 5. When we're at t equals 1, we're still approximately at that same y value. We've maybe moved a little bit downwards, But from t equals 0 to t equals 5, we are basically just moving horizontally. There's very little vertical movement. So when t equals 1, we are just slightly a bit down. But then from t equals 1 to t equals 2, we move down a bit more. Since we are vertically decreasing our y value from t equals 1 to t equals 2, our new y value at t equals 2 is about y equals 2.5. Now from t equals 2 to t equals 3, our y value keeps decreasing because, again, our vertical movement of those points is downwards. So we're starting off at y equals 2.5, but then we're ending at y equals 0. Next, going from t equals 3 to t equals 4, again, there is vertical movement downwards, so our y value continues to decrease, and it looks like we're decreasing, well, a little bit past minus 2.5. So at t equals 4, we're a little bit past minus 2.5, so maybe somewhere around there. Now from t equals 4 to t equals 5, we are continuing to decrease that y value because the vertical movement is downwards. So we go from about a little bit beyond minus 2.5 to just slightly above minus 5. So our y value is just slightly above minus 5. So somewhere, let's say, about there. Oops. And then finally, from t equals 5 to t equals 6, there's very little vertical movement between those points. Maybe we move downwards just a little bit to y equals minus 5, but there's very little movement vertically between these 2 points. So between these 2 points, maybe we move just slightly downwards, but our coordinate function for y of t looks something like that. So again, when we're looking at the coordinate functions x of t and y of t, extracting that information from a parametric curve itself, for x of t, we're really asking what's happening with the parametric curve. Are we moving to the right? Are we moving to the left? Because that would indicate an increase in x or a decrease in x. And for y of t, extracting that information, we're asking point to point, are we moving vertically upwards? Are we moving vertically downwards? If our y coordinate increases from point to point, we are going from a lower point to a higher point, or vice versa. If our y coordinate is decreasing, we're moving from a higher point to a lower point.